Hello friends, welcome back to my channel. So in this tutorial we are going to look at this MIT integration B question. This is 2025 semi-final question. So let's start off by rewriting this integral. So we have I to be equal to the integral of x plus 24 divided by x. Factorizing x out will be x squared plus 25x plus 144 dx, right? And this one, the denominator, that is x squared plus 25x plus 144. Solving this one quadratically, this one can be split into x plus 9 times x plus 16, right? So this one will give you this one, right? That is how this one can be solved. That is, the roots are 9 and 16. So we can replace that in our integral. So the integral of x plus 24 x plus 24 divided by x times x plus 9 and then x plus 16, like this dx, right? So let me switch colors, then we work with this. This is a partial fraction now, so I'm going to forget the integral for now and then deal with the partial fractions, and then I'll come back later on and deal with the integral, right? X plus 16. So let's use partial fractions to really see how we can split this one down. So this is a over x plus b over the second factor, which is x plus 9, plus c over the third factor, which is x plus 16, right? And we can use the partial fraction. So the LCM here is x times x plus 9 times x plus 16. And this one we have x plus 24 here at the top, divided by x into x plus 9 times x plus 16, like this. This is equals to, now we can multiply here. So this is a multiplied by these terms here, right? So a multiplied by these terms here is the same as the original one, which is x squared plus 25x plus 144. That is this term multiplied by this term, plus b multiplied by this term and this term. That is going to be b multiplied by x squared plus 16x, plus c multiplied by this term and this term. That is going to be x squared plus 9x. So the denominators here are the same. We can forget about that and then focus on the numerators. So the numerator x plus 4 on the left hand side is equals to this one. Expanding this one is going to be ax squared plus 25a x plus 144a, plus this one is bx squared plus 16bx plus cx squared plus 9cx. We can group some like terms. So this is a plus b plus c all times x squared. The coefficient of x squared is this a, b, and this c, right? Plus the coefficient of x, which is 25a plus 16b plus 9c. That is x. That is this guy, this, and that guy. And then plus the constant here is just 144a. So comparing both sides, we have a plus b plus c to be equal to 0. There is no coefficient of x squared in the left hand side. Call this equation 1. Equation 2 is going to be 25a plus 16b plus 9c, and that is equals to 1. The coefficient of x in the left hand side is 1. And then call this equation 2, and then the constant term in the right hand side is 144a, and that is equals to the constant term in the left hand side is 24. So we can already find a from the last equation. You can call that equation 3 if you want, but then we can find a from there, right? So if you have 144a, so a here is going to be 24 over 144, and that is equals to 1 over 6, right? And then we can solve for the other two values, that is b and c. So a is 1 over 6, and then plus b plus c is equals to 0. That implies that b plus c is equals to negative 1 over 6. You can call that equation 3. And then we can also plug the same in here, which will give you 25 times 1 over 6, and then plus 16b plus 9c is equals to 1. So 16b plus 9c is equals to 1 minus 25 over 6. That's negative 19 over 6. We can call that equation 4. What we are now going to do is we are now going to solve equation 3 and equation 4 simultaneously to find the values of b and c. So let's do that. So this can write b plus c is equals to negative 1 over 6 here. This is equation 3 just from here. Nothing new. And now we can recognize that we can multiply equation 3 by, let's say, 9. So when we multiply equation 3 by 9, that is going to give you 9b plus 9c is equals to negative 9 over 6. Right? Can call that equation 5 if you want. And now we are going to do some subtraction. So equation 4 minus equation 5. When we do that, we are going to have 16b minus 9b, and that is going to give us what? 16 minus 9, that's going to give us 7b. And then 9c minus 9c will give us 0, and that is going to be equal to negative 19 over 6 minus negative 9 over 6, right? And that is going to give us what? That is going to give us negative 10 here over 6. And that is equals to 7b. So in that case, we can divide both sides by 7. Dividing both sides by 7 is going to be, so in that case, b is going to be equal to negative 10 over 42. And that is equal to negative 5 over 21. So that is the value of b. What about c? We can find the value of c from equation 3 here, right? So if we have b plus c to be equal to negative 1 over 6, and we have b to be negative 5 over 21, that means c is going to be equal to negative 1 over 6 minus b, and b is negative 5 over 21. So that implies that c is going to be equal to negative 1 over 6 plus 5 over 21. We can find this LCM here is 42. This and this is negative 7 plus this divided by 21 is 2 times 5, which is 10. So that is 3 over 42, and that is equals to 1 over 14. So that's the value of c, right? So after all this algebra, the value of a, the value of b, and the value of c has been found. So we can now wrap up our integral. So this is the heavy lifting that we have done. So a is going to be equal to 1 over 6. That is the very first one we found from equation 3. That is from here. And b is equals to negative 5 over 21. That is from here. B is equal to negative 5 over 21. And then c is going to be 1 over 14. So these are the values of a, b, and c that will satisfy our equation. So we can now go back here to our partial fractions. Here we can now split our integral this way. A is 1 over 6, so that is going to be 1 over 6 multiplied by 1 over x, right? Plus, what is b? B is negative 5 over 21. That is negative 5 over 21 times 1 over x plus 9. And then c is 1 over 14. That is plus 1 over 14 times 1 over x plus 16. So this one is how our integral can be split. So x plus 24 divided by x into x squared plus 25x plus 144. The integral of this one dx, this is the same as a over x, so that's the same as the integral. A is 1 over 6 times 1 over x plus b. B is negative 5 over 21 times 1 over x plus 9 plus c. C is 3, 1 over 14. I'm sorry, that is 1 over 14 times 1 over x plus 16. All this one dx. That is from our partial fractions here. That is from here. Okay, so now let's switch back to the white pen and then wrap up the integral. Now that we have done this one is going to be easy. This is 1 over 6 is a constant. We bring that one out, 1 over x dx minus 5 over 21 is a constant. To bring that one out, the integral of 1 over x plus 9 dx plus 1 over 14, the integral of 1 over x plus 16 dx. And this one is our integral I. So this is 1 over 6. That is the ln of x minus 5 over 21, the ln of x plus 9 plus 1 over 14, the ln of x plus 16 plus the constant of integration. Yeah, so if we integrate this, x plus 24 over x cubed plus 25x squared plus 144x dx. This one evaluates to 1 over 6 ln of x minus 5 over 21 ln of x plus 9 plus 1 over 14 ln of x plus 16 plus the constant of integration. This is the answer that MIT gave for this integral. So that is how we solve this integral. I think the heavy lifting here was just using the partial fractions and solving for the values of a, b, and c. Once you find the values of a, b, and c, the rest are trivial, and then we can just solve the integral in one line. I thank you so much for watching this video. If you find this helpful, make sure to give me a thumbs up and subscribe to my channel for more content from Calculus Diaries. I thank you so much, and I will see you in the next one. Bye bye.